For 12.3 example 1 letter D, I'm going to go through and calculate the slope of the tangent line, our equation for that, our little formula. The directions in the book again say to find an equation for the slope of the graph of each function at any point. But again, that is just another way of saying find the equation of the slope of the tangent line. Here's the original that we're working on this time. I do see that my highest power of x is an x squared, so this will be a little more complicated than letter A or B, but will be about the same level of difficulty as letter C. A little tougher, but not bad. As part of our slope of our tangent line formula, one of the things I am going to need to calculate is f of x plus h. So let me do that first, and then we'll simplify it just like we did in the other problems. I need to take x plus h and replace that everywhere where there's an x up above. So wherever there's an x, I'm going to put in an x plus h. The first term was 5x, but in place of that x, I now need an x plus h. Then the next term is a minus 2x squared, but in place of the x, I need an x plus h. Then finally on the end, that plus 8. I need to get rid of these parentheses and simplify at some point. It's easiest to do it now before we plug it into the formula. Based on PEMDAS, I know that I need to do exponents before I do any multiplication. So in my next step, I'm going to go through and evaluate this x plus h squared. I need to do that before I multiply by the negative 2 because of PEMDAS. So we have f of x plus h is equal to, I'm not doing any multiplication in this step, so I'm just copying that 5 times x plus h down again, and then we have a minus 2, and then on the end a plus 8. What I need to do is I need to figure out what x plus h squared is. Earlier in letter C, we went through and we did that calculation. Here it is again. And again, it is easy if we write this down and then use that in future problems. So in your notes, here is what we did in letter C, but we did say as a final result, when you have x plus h in parentheses, that binomial squared, when you FOIL it out and combine like terms, this is what we get. And if you look at the problem we're working on right now, this is what we are simplifying. So in those empty parentheses that I have right now, I can put in these 3 terms. So here is my x plus h squared. I know that that x plus h squared, that is equal to x squared plus 2hx plus h squared, based on that work that we did earlier in those notes that we took in letter C. And if you have that written down, you can use that on the test or the quiz when you're doing those sorts of problems too. You don't need to show me all those foiling steps. In our next step, what we're going to do is use the distributive property to get rid of the parentheses here and here. So f of x plus h, that's equal to a 5x plus 5h. And then distributing that negative 2 through, we would have a minus 2x squared minus 4hx minus 2h squared, and then on the end, that plus 8 again. If there are any like terms here, we should combine them together, but there's not. That is what f of x plus h is equal to after we simplify it as much as we can. It doesn't look very simple, but that is as good as it gets. Again, the directions on this, we are trying to calculate the slope of the tangent line. So let me remind you that the slope of our tangent line has a formula to it. I've written it down in each of the last problems. I'll keep writing it down each time. Oops. Forgot the limit part. So in front here, we should do the limit as h approaches 0. And then our fraction, our difference quotient, f of x plus h minus f of x, all of that over h. All right, so here's the formula that we are substituting into. We need to know what f of x plus h is, and we do. We just calculated that. Up here, our value for f of x plus h was all of this. So just like I've done in the last couple of problems, I have figured out what f of x plus h is as kind of scratch work, and now I'm going to substitute that in. Next, in the formula up on the top, we do have this subtraction. And then after the subtraction, we do have f of x, and f of x, that is our original equation. So up here, here's our original equation. That's what f of x is equal to. I'm going to substitute that in for that f of x that we have after the subtraction symbol. So again, we have this big fraction. F of x plus h is what I have here in blue. F of x is what I have here in the original problem in green. And then we do have the subtraction in between with that h in the bottom. Next step then is going to be that substitution. Up in the top, for this first part, we do have our f of x plus h, which is everything in that blue rectangle, so I'm going to start by copying that down. Again, you can put the parentheses in there if you'd like, but you don't need to for this part that's in blue. It does allow us to see how things are grouped, but not really necessary. So those are the values that we had for f of x plus h. Then there is that subtraction symbol, and then after the f of x, or after the subtraction rather, is f of x, and that is our original problem. So I'm going to be plugging that in here. So taking the original and plugging it in, I have a 5x minus 2x squared plus 8. And then in the bottom part of our fraction, just that little h that's down in the bottom. So that's what our substitution step would look like. And then from here, predictably, the same thing happens in every single problem. What I need to do next is to get rid of all of these parentheses. The blue parentheses really aren't necessary. There's nothing here in front to distribute in. The subtraction here, though, does need to get distributed into all of these green terms, and there are 3 of them this time. So in our next step, we still would have the slope of our tangent line is equal to, still have the limit in front. Again, you keep copying the limit as h approaches 0 down over and over and over again as you go through and do the problem. Not until the very last step when we substitute in 0 for h do we get rid of that. So just keep copying that down. Again, what we have in blue, we don't need to do anything with that. We can just drop those parentheses off. And then what we have here in green, distributing the subtraction in would give me a minus 5x. Then we'd have a negative and another negative, so that makes a positive, plus 2x squared. And then finally the minus 8 on the end still, with that little h on the bottom. So once you get rid of all the parentheses, if you remember right, we should be able to go through and get a bunch of things to cancel out. What's going to cancel out is all of this stuff in the top that doesn't have an h. So let me just go through this top part from left to right. The first thing I see is that I have a 5x here. That is the first term without an h. And then further down there is a minus 5x, so those do cancel out. This term has an h in it, so that's not going to cancel, but this one doesn't. We have a minus 2x squared, so if I take a look at that minus 2x squared, there is a plus 2x squared there, so those are going to cancel. This term has an h, so that's going to stay. This term has an h, so that's going to stay. This one is just the number 8, and I do have this 8 with a minus 8 out here on the end. So again, we have 3 pairs of values, 6 terms total that are going to cancel out. And the only thing that is going to be left in that next step are just values that have h in them. So the slope of our tangent line is equal to the limit as h approaches 0 of, a little shorter fraction this time. Up in the top, the only things that are left, the 5h, the minus 4hx, and the minus 2h squared. And then down in the bottom, we just have h. After we get all of those terms that don't have h's to cancel, then what we want to do is cancel the h in the bottom with the h's in the top. And to do that, we do need to factor an h in front. Right now, the way things are, we can't cancel out an h on the top and an h on the bottom because of the subtraction that's there. But if we factor an h in front of those terms, that would leave me with a 5 minus 4x minus 2h in the parentheses. Now outside the parentheses, we don't have any addition or subtraction, so now I can cancel that h in the front with the h in the bottom. So we end up with the slope of our tangent line being equal to the limit as h approaches 0 of this h on the top cancels with the h in the bottom, so we won't have a fraction anymore. We just end up with 5x, with just 5 minus 4x minus 2h. All of the work that we just did, again, was chapter 1. We did that way back in October, I think. So it's been a little while since we've done these difference quotients, but we did do that work before. And the only thing that's different in chapter 12 is now at the end, we need to take this limit, and h is approaching 0, so we can take and plug in 0 for this h here. We would do it for all of the h's, but we just have one h there. So the slope of our tangent line is equal to, and I don't need the limit as h approaches 0 anymore because I'm doing that direct substitution step, going to plug in 0 for this h. So we would have 5 minus 4x minus 2 times 0. Well, that's going to get that last term to cancel out. So for our formula, for our final answer, the slope of our tangent line is equal to 5 minus 4x. You could also write that out as a negative 4x plus 5 if you'd like. Either way would be fine. And that is an example of another limit problem where we're finding the slope of the tangent line for a polynomial that has an x squared as its highest power of x.